So, hi everyone. Welcome to yet another edition of Metaflow Office Hours. Today we are going to discuss Zendesk's use of Metaflow. Zendesk is an award-winning customer service software trusted by many hundreds of customers. And we are going to hear from the team at Zendesk. And over to you, Jeremy.
Hi, I'm Jeremy, and I work at Zendesk and part of the machine learning platform team. Here to discuss some of the infrastructure we've set up on Metaflow to offer that to internal machine learning pipelines that we would like to run. So try and pull up some slides. Working. That's showing properly. So the initial what we have to begin with is some EC2 research instances that machine learning engineers, data scientists will be able to run, and they will have access to particular S3 buckets with some training data. They'll have this is sort of their managed setup that they can sort of access, and so from there they would be able to install Metaflow and just run it, sort of learn what they need, and be able to use the local orchestrator there. So that would be their initial building blocks of just have this machine and understand the basics, troubleshoot anything, potentially their code. And next setup.
Sorry, hey Jeremy, is it okay to ask questions as we go along, or should we do this at the end?
Yeah. No, as we go.
So can you go back to the earlier slide? So in this case, like when people were doing this, were people directly SSHing into an EC2 instance and then running Metaflow there, or was it more about, or was there some other automation in place for kind of sort of establishing the link between EC2, S3, and bunch like that, and machines like that?
SSH is their main access.
Okay.
Yep. I mean, we have been using there's an SSH sort of extension to VS Code, which is somewhat popular.
Right.
Underlying, just shelling in, getting access to.
I think just quickly to add on to that as well, right? Like these research instances are not just like plain EC2 machines either. Like we basically use service catalog in AWS. So basically you have templates with like S3, like CUDA versions, like everything's like pre-installed. All you need essentially is like a click of a button. You get like the options to choose like which instance type you want, and like basically like all of that is like pre-installed for you. With like the correct S3 permissions per team. All of that is all set up for you. So it's not bare bone EC2. It's built on top of EC2, but essentially we use service catalog product to do that.
And it's basically, is it through like having your own AMI that kind of sort of enables you to have basically an image in which all the required software components, all the drivers and everything else is installed?
Yeah.
Okay.
Yeah.
Got it.
So all of that is like an AMI that we provide. So when you do like with like different instance types, essentially, there's different AMIs that we have available, and like also like different CUDA versions as well. So like they can pick and choose like, hey, I want to run like CUDA 12. Can I have an P3 instance type like 24x large? And that literally takes a minute, and then they SSH into it and do whatever they want to do after that.
Yeah. And we also leverage SSM is quite nice to be able to run on boot time. So AMI for stuff will be pre-baked, but things that we need to run and actually happen as it boots up, the Amazon SSM works quite nicely for the boot time scripts.
Got it.
Yep. And so these same instances also have access to provision stuff in batch, and so you can have still a local orchestrator, but the batch decorator will work and pass things off. We have a CPU and a GPU queue to access, and that will run on different batch clusters. And both of those will have access to the Metaflow metadata service that runs in our internally managed K8s cluster. And
I see.
yeah.
So in this case, it is using AWS batch, but the Metaflow metadata is running on Kubernetes. That's interesting.
Yeah, and so that has its own database provision. So it's a shared metadata service for all teams, and so they can sort of see the runs and be able to access that. All the history of the flows and stuff. So that's quite nice that we were able to offer that for all teams. And yeah, so I guess we do have different S3 and batch clusters in data locality regions. And so if teams want to run cross-region pipelines, they can run them separately and have them merge afterwards with the merge operator Metaflow. Yep, and then so adding to that, we also offer connection to MLFlow. So both the batch and the EC2 instances can kind of track experiments as so each pipeline could be a different experiment, or they can kind of see how the model is going and use MLFlow to keep a track of particular objects and scores of how those models are going.
I see. So Metaflow by itself also has a mechanism to kind of sort of version data, version the artifacts that you create. It does have tags or other such metadata that you can kind of sort of add to a specific run.
Okay.
So if you want to kind of sort of use, let's say, tag a specific run with, let's say, the F1 score of a model or whatever, some accuracy metric or something like that, then you can add it as additional tags. But was that an option, or was it considered better to actually run this or to have all of this metadata in ML? Actually, what data gets stored in MLFlow? Maybe that's a good
Yeah. A lot of the scoring of the models, and so this was already provisioned, and so we have older experiments that we sort of want to compare to. So I think that was the main drive there. But would definitely be interested in looking at ranking with Metaflow's metadata. So, but the tooling was already Metaflow as well. So
yeah. I was just curious about why. Yeah,
I can add to that as well, right? Like there's two main reasons why we decided to keep using MLFlow as well. One is like not everything runs out of Metaflow at the moment at Zendesk. Right. So to make sure like everything is visible in one spot rather than like splitting it across like two different things as well. We decided to keep everything in MLFlow because there's research instances, then you have Metaflow. We also Metaflow is something that we just started to implement at Zendesk 3 months ago, right? As well, or 4 months ago.
I see.
But before that, we had our own orchestrator and everything that we built within Zendesk a couple of years ago that we've been using. And there's different toolings for training right now. So we didn't want that to be there's island of information available everywhere. We just wanted one place. But there could be a time a year in the future where we decide maybe MLFlow is not the place we want to store all of that. We have Metaflow. But that's pretty much the biggest reason why we decided to keep using MLFlow.
Yeah, that totally makes sense.
Yeah, so so adding if we wanted to run a particular pipeline on a schedule, we recommend we have a Spinnaker setup, and this will be able to allow creating step functions as the orchestrator. So you can still do this directly from those same EC2 machines, but that's more of a dev kind of cycle of being able to see it work correctly. And then once the team has considered it production worthy, that it can run every week or every day, on some sort of schedule, we've created dedicated clusters and queues to sort of, hopefully we're going to minimize, we haven't quite got to this yet, but hopefully we'll minimize noisy neighbor problems, and because everything's shared right now. And so we'll have this manual sort of setup where you've deployed manually, and then Spinnaker will be more of a productionized setup that should run more reliably without, or at least more predictably on noisy neighbors, and we can sort of allocate timing, that kind of thing, with the central deployment mechanism. So that's how we decided to do that piece.
Cool. Very nice.
Yeah. And then as extra features on top of all this, we found that it's if GPU jobs end up in the CPU queue, because we have one queue just with CPU instances, one GPU instances, the default for batch is sort of first in, first out. So if a job is not able to run because it's requesting a GPU, and all the instance types in the cluster will only be CPU instance types, it'll just sit there and just wait indefinitely to get run. It won't go and find other jobs in the queue past that. So for now, we're just sort of going through and checking every 5 minutes. Are there some GPU jobs in the wrong queue, and we're just going to terminate them and tell the user, okay, you need to change your settings.
But once you terminate them, how do you guarantee that they'll go back and run on GPUs again?
Yeah, it's up to the user to change their settings. So they've got wrong settings, and so they need to sort of go and realize.
I see. So the user will see that their job failed, and then they will probably kind of sort of start digging deeper into why it failed. And one option would be that you're running it on the wrong hardware, essentially. So
yeah, it'll also let you know that it got cancelled because it was on the wrong one. It'll send a message back to the user.
Oh, okay. So there's an appropriate error message sent back. Very cool.
Yeah. That'll hit the AWS like API and like describe everything. Yeah. Yeah, and we're also using Lambda to pull out metrics from the batch queue and push this out to Datadog. And so this would be like how long jobs have been sitting there. So this will help teams to have an alerting system if a pipeline is taking too long, or if something else has made these clusters stuck. If for some reason something else is in the way, or there's just too much happening. It'll say if there's something taking too long.
I see. And like you mentioned that you make these metrics to push. So is it push based? You have to send it to Datadog, or is this more like these are published somewhere and then Datadog can read from CloudWatch or something like that, so to actually read the metrics and like have them show up on what are Datadog dashboards or have alerts based on them?
Yeah, these are push. We push read them, but you push, right?
I see.
Yeah, they're sent directly to Datadog. They're not read from CloudWatch.
I see.
These pipeline logs do end up into Datadog, so we do have CloudWatch log being pulled in, but the metrics are separate.
Got it.
Yeah. That's sort of our view of how we've been going with Metaflow.
Oh, nice. I love the step-by-step way in which you go from like something like super basic, like EC2 instance and S3, and then one by one, it's like, adding kind of sort of layers of the onion, adding this. I have one non-technical question for you. All these images that we see on the left-hand side, are these generated using one of these stable diffusion prompt-based things where you gave it a prompt and you generated images?
Yeah. We just got access. Dolly 3 does the prompt improvement with ChatGPT, so you can give it a simple prompt and then it improves it for you. That's yeah.
Yeah, I've been tinkering with some of that as well. In fact, there are some really cool blog posts about stable diffusion and running stable diffusion using Metaflow. So yeah, not Dolly 3, but similar kind of sort of text to image prompts and text to image models on kind of sort of the Outerbounds on the Outerbounds blog about using Metaflow with stable diffusion. And as we've been playing around with it, I was trying to set up also one of these as demos at KubeCon. And as when I was playing with some of these things, these images kind of sort of look familiar in the sense that, of course, it won't be the same image, but it's kind of like feels like, yes, this is like you gave it like a prompt and then it kind of sort of generated an image. So very cool. Very, very cool.
Yeah. Cheers. It's getting impressive.
So can you talk a little bit about the scale of this? Like, how many, I don't know, how many models or how big is the actual processing? So the user submitted flows that run, like how many steps do they have, or how much data do they process, or something like that? Is that some information that you can share?
I can add like a flavor to it and
Sure.
like how Metaflow has helped so far. So this is like pretty new for Zendesk, right? To like get to Metaflow. So like we just have our first EAP customers moving to Metaflow, and they're gonna like start deploying in production, I think next week, essentially. So we have like two pipelines that we are basically migrating to Metaflow at first, and then we have like another two customers we're gonna do by the end of the year at the moment. So the biggest thing that we are doing right now is our biggest problem is cross-region training because of GDPR compliance and then stuff. We have like US data and EU data, and we want to like train all of those within, like it's basically an ensemble.
Yeah.
So we train two models, one in US, one in EU, and then bring it back to like create an ensemble essentially. And that used to take 3 days for a manual person to like do that, like spin up one machine, do that, like run it for a day, do that in another, run it, bring it together. Of course, like it's not like 2 days, like or 3 days, like all together, but like it's more like context switching and everything as well. So what we have done using Metaflow is like have that as like single pipeline where like you can like deploy like step functions in both regions, and then like there's an overarching step function which calls the cross-region pipelines. So one spins up in EU, one spins up in US, and basically then they collate back in US to like make sure it's being processed to create the last ensemble model, essentially. Yeah. And we're predicting that would save like the entire end-to-end pipeline should take like a couple of hours. So that's like a massive like improvement for us from like 3 days to like a few hours essentially. But
that's cool.
Yeah. That, and also like that's our biggest model in terms of not in terms of the model size itself, but in terms of like the customer impact as well. It's like our core bread and butter for Zendesk as well that we're migrating to Metaflow right now.
And how frequently is this kind of sort of model rerun or recreated?
Every fortnight.
Like
every
fortnight.
Yeah.
Oh, nice.
It's gonna be
and that's a fixed cadence that every fortnight you do this. Create a new version. Sorry.
Yeah. So right now it's on a schedule every fortnight, or a schedule means like manually someone would go and like do it. But now that we have got this performance improvement, we might look at doing it even weekly on a schedule as well. Yeah.
Got it. Awesome. And you mentioned something about kind of like doing this for a customer. So as you also want to do this for, I'm guessing, other customers, like it'll be a similar approach. It's just that whatever the cadence might be different or the sizes might be different. Is that fair?
Yeah, that's fair, right? So like within Zendesk, like when I say customer, it's basically internal ML teams
Yeah,
within
sure.
Zendesk, right?
Okay.
So basically, the hope is, or not the hope, the plan is to make sure we migrate every other pipeline into a scheduled Metaflow pipeline in the next 6 months. So
I
all our
see.
models are going to start using Metaflow mid next
Okay,
year, essentially.
got it.
Yeah,
And
yeah.
what type of models are these? As in, what type of data is it? Like typically, is it numerical data? Are these NLP models? Or
Language.
what is
Yeah,
this?
they're all language models mostly.
I see.
Yeah,
I see. Okay.
yeah,
Very cool. Very cool. And I mean, just because it's in the air everywhere, are you guys doing anything with LLMs since you talk
yeah,
about language models?
yeah. We are doing a bunch of things with LLMs.
Okay.
That's how I
Okay.
feel came on video. It's like, yeah, LLMs, all for it. We have our partnership with OpenAI right now.
Oh, nice.
We leverage.
Nice.
But we are
Nice.
also looking to do, like, I know like a lot of people within Zendesk have also tried running their own Llama 2 models locally
Yeah.
and stuff as well. So there's a lot of like, I think it's a big
Yeah.
part of our strategy to
Yeah.
do LLMs.
Yeah. I mean, once you have something running reasonably well, and of course, when you are confident enough about kind of sort of its performance and overall, and if you're open to sharing it, I would love to have another similar conversation at some point about your use of LLMs with Metaflow,
Yeah,
and maybe a similar example. You can do that at some other point, of course, nothing to, I mean, nothing urgent, but just like, I mean, there's so much conversation about LLMs. I mean, as I mentioned, like I'm at KubeCon at a Kubernetes conference. In the keynote speech, there was conversation about LLMs and like how I think some of the NVIDIA folks were talking about using Kubernetes with NVIDIA GPUs for either training or inferencing, based on like how Kubernetes is helping NVIDIA to do training and inferencing using GPUs and stuff like that. So it's uh, the potential and the excitement around it is immense. So it would be great to kind of hear that.
definitely. Definitely. We'll be more
Uh,
than happy to do that.
awesome. Yeah. Well, that's awesome. Thank you so much for sharing all of this. I think this was fantastic. And as I mentioned, like I love the kind of sequencing way of doing this, going from simple, straightforward, like it's just EC2 and S3 all the way to kind of sort of having these complex pipelines with multiple different components involved and kind of sort of role of Metaflow in that. I also love the fact that there is Metaflow, just the orchestration layer, and then there's also the Metaflow service for kind of sort of storing some of these additional artifacts and whatnot. So that's really, really good use of Metaflow and the Metaflow metadata service.